Hi, welcome to Systems Analysis and Design. This is the 11th edition, and as I explained in the syllabus, what I will attempt to do is go through this chapter and do a couple of things. One is I will kind of think out loud on these slides. My intent is not to regurgitate the textbook. My intent is to kind of explain areas and concentrations that I'm interested in. Right before the end or the summary of this, I will go through the chapter activity. If you'll notice, each chapter has an activity that you're supposed to do. What I will do is have a slide or two that will give you a hint on what I'm looking for. So I hope you enjoy this class. If this is your first time with system analysis, I think you'll need to read the chapter a couple of times. It can be quite detailed. Otherwise, sit back and enjoy this video and take notes if you need to. Now, one other thing I want to remind you that for the midterm and final, then there will be questions from each video on the midterm and final. They will be rudimentary enough that you will be able to get the information if you have watched the video. So I would strongly suggest watching the videos and not waiting till the midterm, otherwise you'll have a lot of videos to watch. I would watch these as the chapter goes through. It will help you out quite a bit. So let's get started. Chapter 1 is interesting in that we're going to talk, this will be a long video. The rest of them shouldn't be. I will try to keep these down to 15 to 30 minutes, but this first one may be a little bit longer just because I have a lot of details for chapter 1 that I want to explain as we continue through here. But what you will be required to do is to describe the impact of information technology. And I'm not going to read to you. I just want to kind of reiterate a couple of these and let you all look at this. I'd like to get you in the context of systems analysis and the different steps that you go through to do systems analysis. So enjoy these. I'll give you time to read the videos. I'll also have the slides posted if you want to have copies of these slides. Then that may help you a little bit, or you can just watch the videos again and we'll do the same thing. I will not spend a lot of time on each video, on each slide, because I won't have a chance to do this. One thing you know that information technology is the reason why it's used today is obviously to increase productivity. The bottom line of a business is productivity. The bottom line of a business is to make money. Even for nonprofits have to turn they have to turn a profit. Now, you can't call it that. You have to call it excess revenue, but nonprofits also have to turn a profit. Otherwise, they won't be in business very long. This includes Red Cross agencies or United Way agencies such as Red Cross and churches, and you can go on and on and on. All these nonprofits have to balance their budgets at the end of the year. Otherwise, they won't be around very long. Also, information technology. You have customer resource management and different products that will allow you to maintain this. But it's very useful for us to use. You can see the time clock here, the punch clock. 1953, that was a good year. That was the year I was born. So when I started working, I had time clocks to punch in, and that may still exist now. I don't know why. There's enough technology out there to sign in to a system or sign into something, or even have a proximity device on a cell phone that would alert the company when you're in and out on this. But needless to say, information technology is changing, and it's changing drastically. So what is it? It's systems analysis and design. That's what you're doing with this course right now. For many of you, this course will be different. You'll have to read it a couple of times. It can become complex. I'll try to reduce it down as we go through and discuss the different areas. The components of a system, information systems, are hardware, software, data, processes, and people. You can kind of reduce this down into really computers or the system technology. You can put hardware, software, and data in this, and then you can put processes and people in there. So you really can reduce this down to 3 processes if you want to get it down even lower. But we'll leave it the way the author wants it left right here. and discuss these different things. And as you know from working with computers, with smartphones and everything else, the hardware, software, they are changing almost daily. Data we've not done much with as far as analytics go. There are programs that, in fact, we have one that titled Data Analytics or Business Data Analytics, and trying to get predictive information from this right now. The processes that you go through, you all are going through a process right now in order to earn a degree. And then, of course, the people. By far, the people, out of all of this, the people are the most important. More time should be spent with people than anything else. Some companies don't do that, and that in turn causes huge problems. I'd like to point you to the legacy system down here, and that's what a lot of companies are stuck with, mainly because someone knows how to work with the legacy systems. They're not upgraded enough to do this right now. And it's people. People can be stakeholders. They can be employees. They can be anybody that has a influence on the system. Speaking of being influenced, the business today, you can see that we're mainly operating in cloud-based computing. This recording that I made right now is being stored to the cloud. That saves me hard drive space, and it also keeps me from having to back up every day when I make changes. So that when I was 30, 40 years ago when I started this business, then when I started teaching and working with IT, then we stored everything local. Of course, you know how that goes. If you lost it, you lost it, and it's gone. You got to redo it. But now with the cloud-based technology or cloud-based storage, then we no longer have this. Is it dependent upon, or what is it dependent upon? Obviously the internet. Everything that we base right now with any kind of information technology is based on the cloud. We will be working with all of these throughout. I'd like you to really understand business to customer, because that's where the rubber meets the road, is business to customer. Even though you have a business to business, somebody's still your customer. Modeling business operations, part of your activity is to create something like this. So really watch this system as we go through. I'll talk more about this in just as we get near the end of these slides right here. The business process model I'm interested in for this right now. We don't do enough modeling in our businesses. Our businesses get set up. Now, what do I mean by a model? We set a business up. We buy and sell. We buy products. Products can be even people. We buy businesses or buy products, and then we sell products. Products can also mean services. So we buy and sell those, and sometimes we get caught buying from a vendor and marking it up, excuse me, and then selling it. Sometimes the business needs to look at a model to see if there's a better way. Let me give you an example. I owned a business when I retired from the military. I owned a business. I started a computer business, and in my business, this was a long time ago. This was 20 plus years ago that I started this business. And what I found out that I did sales, service, and training on PCs. So I sold, I built computers, I did services, I trained, and tried to do everything. And so my model was a catch-all. I tried to do everything that wasn't being done, and found out very quickly that I could not do it all, even with hiring more people. You can't do it all, so you've got to find a market niche in what you're looking for. And that is based on your business process and the process that you set up. So this needs to be done and looked at carefully and critically every so often. Here's something that you'll have to do. You all take a look at this. Setting up a business model. You have an event, you have a process, and then a result. You can see how this goes. You have a current method, then you have a method for improvement. The two types of systems we'll be looking at through here. We won't do a lot of analytics through this course, but we will look at a lot of transaction processing. What is that? Well, if you go to a ATM and get cash out and get $20 in cash at an ATM, you just created a transaction process. What happens to that? It gets taken out of the system. It gets taken out of your account. You get notified, and then your account is reduced by $20. You make a deposit at the end of the month with your paycheck. It goes back into your account. It gets added back in. There are no analytics that go into this. This is a plus and minus. It's almost like a payroll. There are no analytics involved. It's simply a process. It's just a transaction. Very little thought goes into this. Just a plus and minus system right here. On the other hand, there are analytics systems that, for instance, if you were taking a trip and wanted to go someplace fun and warm, then you would have an analytics system that may make recommendations. The system may ask you how much money you want to spend, how much time you have, what's your method of travel, and so on. And that would then make a prediction or an analytic based on the answers to this. And then you would, of course, take the trip and everything else would be fine. A lot of this I'll talk about, but I want to talk about it more in the chapter when we get to these specific chapters. I don't want to tie this up too long. Otherwise, I could make these videos quite painful for you all to watch. Information that users need, depending on where you are in your company, whether you're operational or you're a top manager, then you will need different bits of information. The operational employees do not need all the information that the top managers need. Now, that's not keeping things away from them. It's just it's giving them too much information that they can't do anything with. So some of this on this has to go to each other. Now, with the same breath, top managers do not need all the information that operational employees or supervisors need. There's schools of thoughts on this that will disagree with me, saying that the top boss needs to know everything, and that's just not the case. Scientific management, 100 years ago, this was the case, where the bosses knew everything and the employees knew nothing. Those days are changed now, and thankfully they've changed, so everyone has a buy-in for the company and what they have to do. We'll talk more about that knowledge management as we get to these specific chapters. This just goes through and talks about the different ones that need this. Now again, we're back to modeling again, graphical representations of this. Different types of modeling. We will discuss these as we go through. Please pay attention to the different types of models, because this class is going to be dependent, your success in this class is going to be dependent on you understanding the model. We call those phases of a model. And so in order to understand this entire book or this course, you're going to need to understand this right now. Most companies prototype something. What does that mean? It means taking a working version before you put it online and seeing how it will work. What can you tell? Let me give you an example. You are a teller at a bank and you're using one type of software to do transactions. Your bank decides to come out with another or a new improved software. Now, most smart banks don't just replace that system overnight and expect you to learn the system the next day. They will have you model, which means you may be doing the same thing on two different systems until you understand the new system. When I change software programs, I make sure that I keep both programs intact until I understand the newer type. Then I delete the old type. That's prototype. That's setting up a model to see if it works, finding facts, finding different things that will work on this. You will use this. There's a chapter in your book. I'm not going to spend a lot of time on this. This class can go into computer-aided systems engineering or CASE. But if you have an opportunity, you've got the book, electronic or paper, you've got it, you ought to take a look at this and get an idea of what that is. It will benefit you greatly as time goes on. I'm not going to spend a lot of time on this right now either, but I would like you to know what structured analysis is. You can see what this is. It uses a systems development life cycle, or an SDLC. We will spend a little time on that as we go through this book right here. But you are basing this on a predictive approach on what you're doing with this right now. The things that we will look at, the systems development model will do planning, analysis, design, implementation, and then support. All of these have feedback loops. They all feed into the next one. For instance, you can't go in and implement a system without going through systems planning. You have to consider this. This is the basis for this entire class, the SDLC. Please understand the difference in the first one and the second one and so forth. Where do most systems fail? They fail in step one. They don't do enough planning. Detailed planning is crucial for having a good analysis and so on and so forth. We will do each one of these. You'll have chapters dedicated to each one of these, multiple chapters. I think one only has one chapter, but the rest of them have multiple chapters on this. And again, I'm not trying to rush through the slides per se. What I want to do is keep this to less than 30 minutes if I can. So the system support is the first step I've told you is a failure, and the last step is also a failure by not having good support. That's caused by not being trained up properly and not having enough after action and to see what happens and when it gets put into place. You will have to do this in detail as we go through. Object-oriented analysis right now is taking the place of text-oriented, or we used to do code, and now code is sort of going away. What we're using now are using objects when we do programming as opposed to learning lines of code. Let me give you another example. If you want to go to a website, if you want to go to msn.com, then you type in MSN. You don't type in. That's not actually, the site itself is got a URL or a number, 136.45.456.789. That's the code that it understands. So you have to have a translator in order to do this. You don't care what that number is because it would be hard to memorize all the numbers, but you do memorize the site names. So there's a process that changes this over. Very akin to what we're talking about as in right now. The methods right here, planning, analysis, and design. I love this model right here because it just continually goes in a circle. That design has to go back into more planning, back into analysis, back into design, and so forth. What do you take out of there are prototypes, and then you do testing. When you do testing, you go back into the model. How much do you do that? You do it till you get it right. The technology department is usually set up with a director or a CIO, depending on the company size. The information technology is based on more networking and telecommunications. The CIO is based on more information knowledge technology. In a large organization, the IT department would fall up under the CIO, and then the CIO may even have a financial section and something else to this right now. But we'll stick with the information technology right now. And what we have, you can see the different support elements there. These next slides just kind of give you a little blurb on each one and what they do. I would learn these. I wouldn't say memorize them, but I would learn what they're doing. And you know, you all may not become IT managers, or you may, but if you're not, based on your degree, you're going to be in management someplace, and so you're going to have to know what the IT section does. So that's why I would learn these, to see what they're doing, see how you're working with this. The systems analysts, what do? Well, they analyze. They're becoming more and more important. They're also called data scientists. Data scientists. That's a new buzzword for the last 10 years. It's becoming more constant now. A lot of data scientists have PhDs in analytics. They have a good way to conceptualize and to analyze data. Who do they work for? Typically the CIO or a director. Most of the time, the analysts that I have seen are not in the direct chain of command. They're in a side chain of command, which means they kind of operate much as an accountant would operate. An accountant may be, one of the highest paid persons in an organization, the chief of accounting, but they would not be you wouldn't work for them as a line. So it depends on how your company is set up. You can see the different roles right here that they do. Good paying job. Systems analyst, fresh out of school, that understands. If you understand this course real well, 65 would be a good annual salary, plus benefits, of course, for a newcomer in a systems analyst with a 4-year degree and maybe a little bit of experience in company processes. And experienced systems analysts, they all earn 6 figures. The ones that I know all earn 6 figures. You can see what's required college-wise. This course will not, or this degree program will not qualify you to be a systems analyst. So what I would do is, if you are interested in this, and I've encouraged several students that do very well in this course, I've encouraged them to get a master's degree and learn more about systems analysts. Is there a systems analyst degree? Not really, but there are degrees that go more in depth to systems analysis than this course will do. Again, career opportunities. It's much like in engineering with companies. Engineering can go in a lot of different directions on this. Kind of moving towards the end of this chapter right now. You have trends. IT is one of the fastest evolving industries. Are there IT people out of work? Absolutely. Most of the ones that are out of work are the ones that aren't current, though. They're the ones that still program in an old language, or the ones that aren't caught up with today, don't understand cloud computing or something else right now. Now, your chapter activity, you're going to be called on to develop a business profile. You will read about that in your activities. These are just some of the processes that you will look at. I've only listed 5. There are more. Please consider more. I just listed 5. That is the first thing that you will do. The second thing I would like you to do is to draw a model. I've given you a rudimentary, just to, you'll have a input, and then you'll have processes, and then these are a couple of examples right here. You will use processes, will use input, and then you'll have more than that, though. Then you'll have an output. So if you'll look back at your textbooks, you should see what this is right now. So that's it for the chapter. I'm not going to go through and talk about much more. Here's some of the summary of this, and what we talked about was hardware, software resources, the components of this right now, and I gave you my rendition of that. The different types of information systems, and this is a small list right now. There's not enough slides to put every different type on here. But I will say that what you need to really understand is even as a non-IT person, you'd understand some of these processes that get done. Otherwise, you will be in trouble as a corporate person. Now, you're going to get a mom and pop job and stay local, then no. This probably won't do a lot for you. But if you intend to go into any kind of industrial, commercial, larger corporation, then you're going to need to know some of this right now. So that's all I have. I kept it under 25 minutes, so I hope you got something out of it. I will try to take bits and pieces of this throughout the semester. Good day.